Hi everyone, welcome to our webinar on paleontology. I am a prospective student advisor here at Flinders. My name's Chelsea and I have Professor Gavin Prideaux here with me today as well, who is a professor, researcher and the university's research and media expert on paleontology. So during the webinar today, if you have any questions at all, please feel free to use the chat function. So I'm not sure if anyone watching has been to Flinders University before, but we are about 20 minutes south of the CBD in Adelaide along the coast. So we're on a beautiful open campus on about 200 hectares of land. So there's beautiful outdoor spaces and beautiful views over the ocean and the city. At Flinders, we're really proud to have achieved some of the things that are on the screen, which is actually voted by students. So we are #1 in South Australia for teaching quality and the overall education experience, so balancing both the theory and practice and practical elements as well, and also the work-related knowledge and skill development that our students gain. So people like Gavin, who are teaching at the university, have specialisations and have embedded themselves within their teaching profession, but also in the industry as well. So our students find that really valuable. And we've also voted #1 for student spaces and teacher-student ratios as well. So small class sizes, so you can really get that engagement with your teachers and your tutors. When we've recently launched the Student Hub, which there's a picture of behind us, but that launched a couple of years ago. So it's a really beautiful space for our students to get together and either do their academic studies or for the social aspects of university as well, and careers fairs and things like that. So that's all accessible to our students 24/7, and so is our library and also our gym on campus. And if you're watching from a regional area or from interstate, we also are the only university within Adelaide to offer on-campus accommodation as well. So if you have any questions about either of those, please let us know. But I will hand over to Gavin to chat about our paleontology course, and I'll jump back on once Gavin's finished with the course specific information and help you out with some more important dates and things like that. So thanks, Gavin.
Thanks, Chelsea. So it's great for me to be here today to have a chat to you about the Bachelor of Science in Paleontology, which is all fresh and new in 2019. So is that going to be the first slide that's up? Is that what's on the slide right now?
Yeah.
Okay, cool. So yeah, I'm the Director of Paleontology at Flinders. We've got several academics in our group, and I'm going to talk about what some of those people are interested in and the students that work with them, what kind of work that they do. But before I start talking about the degree itself and different aspects of the program and what we emphasise, I just want to give you a little bit of background to myself. So my expertise are on Australian mammals, and I'm really interested in how they evolved. They're really unique compared with mammals in other parts of the world, and how they responded over time to environmental changes, so climatic change over time, what influence that had on their evolution and their ecology, and also looking at the impacts that people had on these animals when they arrived in Australia. I actually studied myself at Flinders, so I can vouch that even though that was quite a number of years ago, it's still the same awesome place to come and study at a university. It's a fantastic campus. The staff are really good in general. It's true what Chelsea says about the smaller ratios of students to staff, and also just the approachability of the staff in general. It's a pretty relaxed place to work compared with some universities. So I studied here through to the late 90s, and then I moved away and studied at the University of California, and I was at Narracor Caves for a while in southeastern Australia, then moved across to the Western Australian Museum on different short-term contracts, and then I ended up back at Flinders in 2007. And the kind of work that I do means I need to collaborate with a lot of different experts in fields, so archaeologists, geologists, people who study climate, molecular biologists, and that's one of the things that's really fantastic about paleontology as a field, is it's very multidisciplinary. You need to know a lot about a lot of different things, or work with people who are experts in a lot of different areas, and that's sort of reflected in the undergraduate program, as I'll talk a little bit about shortly, where it's not just paleontology that you're learning about, but it's a whole range of other associated fields that form the foundation for understanding in paleontology. So our group here, our research group, here is half the people that weren't scared to have their photo taken standing in front of our fancy new billboard on the way into the campus. We have the largest group of paleontologist researchers in Australia, so that's all the 6 academic staff and 30 research students and support staff. So it's probably more than double the size of any group in Australia. And if you want any more information specifically on it, what we do here, you can go to flinders.edu.au/paleontology, or also the Flinders University Paleontology Society webpage, which is a student-run society that people can be involved with, even if they're not doing anything on the way of formal study, and that's flinderspaleosoc.org. So what is paleontology? Well, in general, and in the most sort of simple terms, it's the study of fossils. What are fossils? Well, fossils are evidence of past life. And so people often get paleontology and archaeology mixed up. In fact, archaeology is really focused mainly on study of human activities and human culture. Paleontologists study everything else. In fact, we often work with archaeologists because they're often finding animal bones or plant remains in association with their artefacts, and paleontologists are often sort of involved with that work. So we're pretty general and cover a lot of different areas of interest. And as I mentioned just before, it's very multidisciplinary. So what is it good for? Well, everybody knows it's good for entertainment, because there's always movies coming out every year, at least one or two, that are built on paleontological knowledge or some abstract form of it. Every year, like Jurassic World has just come out, everyone's fascinated with dinosaurs and giant sharks and things like that, so there's lots of mileage in that for entertainment purposes. It's also related to that to a degree is the way that paleontology is used in science engagement. If you go to natural history museums, one of the key components of most displays in museums is the fossil gallery, or the exhibitions that they have. Part of the reason for that is that paleontology is really hands-on, interactive. You can see it. It's a really useful hook into science for kids. And so we sort of perceive some potential with some pathways there for graduates of this program. It's also good for reconstructing climate history. So there are types of paleontologists called micropaleontologists, and they study the remains of tiny little organisms that are preserved in the bed of the ocean or in lakes, where cores can be drilled into those lakes in the bottom of the ocean, and you can look at which species are preserved of these microorganisms up the core, and use that to reconstruct climate history, because they have a certain amount of chemical information preserved in their little bodies that from which we can get information about sea level and about temperature, which allows us to reconstruct climate. It's one of the reasons that we know what Earth's climate was like in the past, is from micropaleontology. Associated with that, and essentially using the same methods, is the use of micropaleontology in hydrocarbon exploration. So cores can be taken similarly, and there are in association with fossil fuel deposits, whether it be oil or gas deposits or coal. There are often remains of these little organisms that always occur in association with those particular deposits. So when you take a core and you find remains of those particular species, that's where oftentimes they'll then explore that layer further until they hit hydrocarbon deposits. But the kind of stuff that we're really is our main focus at Flinders University is reconstructing the history of life. Most of the paleontologists here that teach and do research at Flinders are interested in evolution and ecology, and most especially of vertebrate animals, so that's animals with a backbone and internal skeleton. And one of the people in our group that leads the way in that kind of research is John Long. He's a professor of early vertebrate evolution, so he's really interested in some of the questions that are posed on this slide here. When did live birth first evolve in vertebrates? When did they first move on to land? When did they first start having sex? All this, these are the kinds of questions that he's really interested in, and it's way back in time. You're talking about 400 million, 350 million years ago, so right in the early days of vertebrates and when they first started to move on to land. Then there's Mike Lee. He's more of a reptile expert, or he's interested in a lot of different things, but reptiles are his forte. He's looked at dinosaur evolution and how they evolved into, one group of dinosaurs evolved into birds, as well as being involved in some earlier stuff, for example, looking at when complex eyes first evolved in the Cambrian 500 or so million years ago. But as I say, reptiles are really his forte. Then there's Trevor Worthy, who's one of the foremost bird paleontologists on the planet. He's also based at Flinders, which is a great privilege for us. And he's really interested in looking at the fossil history of birds in Australia and also New Zealand, and looking at what roles that birds played in the ecology of Australia in the past and how they're all related to each other. So one of his pet groups is these giant birds that used to live in Australia, who they're now extinct. They went extinct about 50,000 years ago, but that kind of looked like giant emus but weren't giant emus. They're in fact related to ducks and geese and chickens, and they were pretty distinctive component of the bird fauna in Australia up till only a few tens of thousands of years ago. Then there's Aaron Kamens. He's got similar interests to me. He's interested in the mammals, but he's a real expert in looking at the skeleton of these animals and working out how they moved and where they lived. And he also studies fossil trackways. So that slide at the bottom left there on your screen, that's a set of fossil trackways of a diprotodon, which is the largest marsupial that ever lived, the size of a rhino, that's preserved in rock in a lake bed in Western Victoria. And so you can get information from trackways of animals that you can't get from just looking at their bones. And he's found thousands and thousands of trackways in recent years from different parts of Australia, and that's given us new and different insights into the life and times of these amazing creatures. And finally there's me. I'm interested, as I mentioned before, in mammal evolution, most especially marsupials, and within that kangaroos are my real favourites. Up until only a few tens of thousands of years ago, we used to have lots and lots and lots of different giant kangaroos around, including ones that had a really short face, that were not grass eaters but ate leaves and twigs from trees. And I'm really interested in tracking how they were shaped by climate change and why they all became extinct soon after humans arrived. Was it due to human impacts, or was it due to climate change? And it wasn't just those big kangaroos that became extinct, but all animals like diprotodon and giant wombats, giant echidnas, giant Tasmanian devils, giant goannas. There are a whole range of different giant animals that we sort of collectively dub the megafauna, and trying to get to the bottom of that age-old mystery is one of the main areas of our research. So moving on to away from the sort of research that we do, which is of course imbued in all of the undergraduate program, but into the nuts and bolts of the BSc Paleontology itself. So what's the course about? It's about in the broadest sense, exploring and interpreting the history of life on Earth, but with a special focus on Australia, the history of Australia, because Australia has a really unique history, and its fauna and flora, consequently, is really quite different to other parts of the world. And the truth of the matter is, it's been really poorly studied and explored overall. So it's a really sort of exciting time to be involved in this field. We imagine that our graduates from this course will come out of it with a broad foundation in paleontology, but not just paleontology, allied disciplines in biology and ecology, in environmental science, in geology, in archaeology. So we are actually working closely with archaeologists, and several of the topics involved in this degree are archaeology topics. So we're trying to look at what opportunities we can generate for crossovers between different areas. Also visual arts, we've got a new topic next year that starts next year on scientific illustration, that's run by the visual arts people. And so we want people to come out of this degree with is not just a really specialised academic knowledge about a few particular areas of paleontology, but we want them to come out with a range of skills that are transferable outside of paleo, that are related to research, the way you analyse data, the way you communicate. So we're very strong in paleontology with public outreach and working with school groups, and it's embedded in everything that we do. So development of communication and education skills is one of the outcomes that we'd expect graduates to have, and a lot of field work, a lot of lab work, and museum-based work as well. So it's lots of hands-on opportunities. It's that hands-on sort of focus is one of the main threads of the course. We don't assume any knowledge coming into it. It'd be helpful for people to have Year 12 biology or and English and maths, but it's not really essential. The way that first year at Flinders is structured is it covers a lot of those basics, or recaps a lot of the basics that are covered in Year 12 anyway, so you can probably pick it up okay. So what are some of the highlights of the course? Well, as I've sort of said numerous times, it's synthetic, integrated, so there's a field, lab, computer, theory-based learning, and combines multiple different fields like environmental science, archaeo, biology, visual arts, and scientific communications. As I mentioned, it's hands-on, and we really like to get people involved with research projects from first year. We don't traditionally, you come to university doing maybe doing lectures and labs, prac classes for first and second year, and you might get involved with research projects in third year. We actually have an emphasis in getting people involved in research, real research, not just pretend research, but being involved in real research programs run by the academics in first year. And the other opportunity is to get involved with community outreach activities, and also be involved in field trips that's run by the Flinders University Palaeontology Society, which is strongly affiliated with our Paleo Lab, but run by students, not academics. And what we essentially expect people to come out with is being trained at a world-class level. So we've got amazing facilities here. We had labs and equipment installed just a few years ago that was the university invested a heck of a lot of money in. So basically it's made us the leading paleontology group in the country. So it's a really ideal learning environment that integrates research, teaching, and community activities. So globally competitive training is what you'll get here if you're interested in paleontology. We're not training people up for local jobs to be competitive for local jobs. We're training people to be competitive worldwide. There's possibilities for, if you're really interested in that sort of academic pathway of going on in research in either universities or museums, which is what is probably the most traditional pathway. But there's also a whole range of any academics, either in museums or universities, need research and technical support staff to prepare the fossils, to help out with fieldwork, to manage collections. So there's all sorts of roles there. If you're not totally academically motivated, but you're still into paleontology, there's opportunities there. And And the same with outreach and education. We work a lot with school groups and closely with the university, people like Chelsea and her group in that regard, and that we sort of see a future there in that sort of area. Also, environmental and ecological consultancy, fieldwork, a degree like this is going to set people up well for that. And we've also started working with people in the visual arts and also CDW Studios, which do a lot of computer animations, reconstructing things like creatures for computer games, but at the same time a lot of that technology can be used for documentaries and paleo artistry. So we sort of imagine a creative line within the BSc Palaeontology there as well. So that's pretty much all I have to say. It's, as I say, it's a new degree. It's 2019 it starts, so it's a pretty exciting opportunity for folks, and it's the first and only in Australia. So yeah, have you got any questions?
Awesome, thanks Gavin. If you have any questions, please send them through via the chat. I can see we have a couple there at the moment. So there's a question, does the course also contain information about other countries as well as Australia?
Yeah, do you want to type it out? Do you want me to?
You can answer verbally now.
Oh, okay, no problem. All right, yeah. Yeah, absolutely. It's very sort of like the focus is the narrow focus is Australia. So there's lots of Australian examples, but everything's put in a global context. So the fossil record for North America and Europe and South America, Asia is really well known. So we totally bury into that and compare what we find, patterns we find in Australia with that elsewhere. So basically, it's an opportunity to sort of get a global perspective, but with an Australian focus.
Yep. And are field trips compulsory within the course?
Yeah, but the field trips don't come in until, so there'll be one in the second half of second year, and that goes for 5 days. So that's in the mid-semester break. So when is that? That's October-ish in second year, and that'll be for 5 days to the Narracourt Caves. You probably could get out of that one, although it will be a little bit tricky. But you know, it's happened in the past that we've been able to work around people for whatever personal reasons not being able to come on field trips. So we'd just take it on a case-by-case basis. In the third year, there's a field trip that'll be, we're not sure where, it might be to Kangaroo Island, might be to Central Australia. That's in the mid-semester break of third year. I'd say that's a pretty strong field focus. I think it'll be a real trick to miss that one. But again, we're always happy to work with individuals on a case-by-case basis.
Yep, cool, thank you. If you have any other questions, please keep them coming via the chat function. And if you have any course-specific questions for Gavin while he's here, I'll go through one slide just to give you a bit more time to think about the course-specific questions. But otherwise, after the webinar, I'll hang back for a few moments and chat one-on-one with you once Gavin has gone back to the lab. So
Going back to my computer.
So essentially, applications through SciTech are open now, and there's an additional closing date coming up for the 3rd of December, but as long as you have your course preferences finalised by the 3rd of January next year, you'll be considered for the main offer round on the 15th of January. There is an early offer round that is coming out on the 20th of December this year. It's a trial from SciTech. So if you meet guaranteed entry into paleontology and it's your first preference, then you may receive an offer on the 20th of December. But if you don't receive an offer on this date, don't panic. The main offer round is the 15th of January. So just keep an eye out on your emails from SATAC, and give us a call at any point throughout the application process if you have any queries or concerns. There has been quite a lot of interest shown in paleontology, but the applications are still coming through, and the preferences won't be locked in until the 3rd of January. I'll just go through some of the other questions that are coming through now. So I will get back to you on that privately, Melanie, about credit. But if there's no more questions for Gavin, we might turn the microphone off in a moment. But what do you think about employment opportunities?
Yeah, look, I think definitely really good. Particularly, if you look at any one spot, maybe there aren't very many paleontology jobs, but as I mentioned, we're training people to be globally competitive, and so if you look around the world, there's lots and lots and lots of paleontology jobs, and jobs in areas that are associated with paleontology. So they're really, really, if you're well trained and you're committed, motivated, it's like anything. You'll find an opportunity, no doubt about it.
I think we ran a session launching this course in June, and we mentioned some career opportunities in working with mining companies and things like that as well.
Yeah, for sure. Lots of, it's very field oriented. So being able to, if you're interested in the outdoors, maybe not even necessarily paleontology, there's a lot of skills that you pick up within this course that will be transferable into other areas like geology and mining.
Yeah. We have a really great career service here at Flinders as well that you can tap into as well. So there's mentor programs. So if there was a particular field that you wanted to go towards, they can actually match you with a mentor within the industry. Or there's all sorts of careers fairs and things that they put on too. But you can actually meet with a career development consultant once you're a student at Flinders, and they will help you work through the job opportunities coming up and the transferable skills that Gavin was talking about, to help you draw that out onto paper and help you, I guess, investigate some other career pathways as well. And you've got access to them up to a year and a half after you graduate. So even if you get a internship, say, for a year, once you graduate, you can still come back to the university and have some more help in finding a permanent job after that as well. Do you prefer lab work, academic research, or field work?
Well, it's hard to say. I mean, I actually like all of it. I don't always get to do it because most of the time I'm sort of stuck in front of a computer answering emails and managing stuff these days, but all my students and lots of other researchers in the lab are doing that. And so, in answer to your question, I love doing all of those things. I probably don't personally get as much of a chance to do it as I used to, but fieldwork is probably the pinnacle because, you're out there actually in nature, maybe working in caves or out in the desert and discovering stuff that no one's ever seen before, and there's nothing like the buzz of actually digging something up and realising that you're the first person to ever see something. And then if it's something new, that's like a super additional buzz. So I don't know, there's not too many actual fields that you get that opportunity, so it's probably the pinnacle.
Good question. Well, thank you so much for your time today, Gavin.
Thank you.
I will turn the camera and the microphone off shortly, but I'll hang around and I'll scroll back up and just make sure that we've answered all your questions in terms of applying and transferring and credit and things like that. But if you have any other questions, feel free to take a screenshot of this screen so you've got our phone number and email address as well. And we also have some upcoming webinars coming up too, so feel free to sign up and subscribe for those. So thanks very much. As I said, we'll hang around and just make sure we've answered all your questions. But Gavin, there's one more question for you.
Question, awesome. What is this one?
Which area of academic research do you think needs most research right now?
Oh my gosh, there's so many. How long have you got? Oh man,
it's endless.
Yes.
Probably.
Yeah, there's lots and lots and lots. Look, one of the huge like focuses at the moment with paleontology is like learning impacts of past environmental change and making predictions about using it to make informed predictions about what change are going to occur in the future with regard to climate and its impacts on likely impacts on species into the future. So that's an area that is like going to be productive and useful for a long time. But this is Australia. Our understanding of the fossil record is like North America's 100 years ago, or Europe's 150 years ago. We're a long way behind on but we're still discovering really new things all the time and making basic discoveries. But the huge cool thing about now is that we have all these amazing technologies that can be applied to that basic research. So it's a very exciting time to be in the field, and there's no better place than Australia and Flinders for studying it.
Mm-hmm. So very relevant since all the news of climate change at the moment. Yeah,
exactly.
Yeah. All right. Well, thank you so much. We will turn the camera off, and please continue to send through any questions if you've got that. So thanks for joining us.